All right, we're going to talk about even and odd integers. This is a pretty common thing to find in like a number theory problem. So if I have this expression 2m, or for that matter 2n, this expression will always represent an even number. Every even number can be represented as 2 times something, or 2 times something. Or you can think about this expression will always represent an even number. So I can plug things in. 1, 2, 3, 4. I'll plug in m numbers here, and I get 2 times 1 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8. Okay. So no matter what I put in for m, I always output an even number. And the other way around, if I think of any even number, like say 102, well, I can work backwards and divide by 2 to get 51 was the number that was plugged in. So I can always take a number, an even number, and represent it using this expression, 2 times something. And the same would be true for, n. I'm just changing the variable. That's it. So n over here is, something like, oh, I wrote an m here. n, 3, 4, 2, 4, 6, 8. Maybe if I wanted to find out what 38 was, I work backwards, I get 19. Okay, so if I plug 19 in here, I get 38. Any even number could be represented using either of these expressions. And the only difference between them is here I use m, here I use n. So the question then is, if I add 2 even numbers together, how do I know I always get an even number? I mean, we know this. Add together any 2 even numbers, we always get another even number. But can we prove it? So here is how we would go about proving that. I would call the first even number 2m, and I would call the second even number 2n. And then I can use kind of the reverse distributive property thing to write this as 2m plus n. And I'm claiming that this will always be an even number. And we can kind of check here. If I make a little table, I've got m, n, and 2 times m plus n. And let's just plug in some numbers. If I have 1 and 3, I get 2 times 1 plus 3. But 1 plus 3 is 4, so this is equal to 2 times 4 is 8. Okay. And over here, say I did 2 and 7. So 2 times 2 plus 7, well, 2 plus 7 is 9, times 2 is 18. I'm still getting even numbers. If you think about it, whatever I pick for these, I'm just going to add them together, and essentially, if I could call the sum of m plus n, I could call it something else. I could call it k. And so this rule would really be just 2k, because k is m plus n. I can take any 2 numbers, add them together, and I'll just call the sum k. And then I'm stuck with a rule. I have a rule that's just like these, 2m and 2n, just with a different variable. Okay? So that's how we know that the sum of any 2 even numbers is another even number. Okay? Because 2m is always even, 2n is always even. I add them together, and I can use this distributive property, this sort of reverse distributive property thing, to represent it as 2 times something. And that could be rewritten as 2 times a single variable, right? Because I can come up with a rule, for whatever, whatever my m and n are. It's pretty easy to calculate k. And if it's in this form, 2 times k, then it's really no different than these 2 rules, and we already know that those rules always output even numbers. There we go. So the sum of 2 even numbers is always even. Next we'll have to talk about odd numbers.